if we're going to graph polar equations, it's going to help a lot if we can classify them. So let's look at the different types that we're going to have. We're going to see some circles. And something called lemniscates. Lemniscates kind of look like bow ties. But I guess you need to pay attention to the equations. That's how you're going to tell. And so a circle might look like this. It might look like r equals 2 cosine theta. Or r equals 3 sine theta. And pretty much, as a general rule, if you see cosine, it's going to be oriented on the x-axis. So that doesn't always make the case for the y-axis, but what will always happen is if you see a sine, it will not be on the x-axis. So your rule is if you see cosine, it's going to be on the x-axis. Some part of it's going to be on the x-axis. So this lemniscate over here might look like r squared equals 9 sine 2 theta. Or sometimes you'll see it if they square root both sides, be plus or minus square root of 9 sine 2 theta. Something like that. And so then this other one, r squared equals 4 cosine 2 theta. Again, if you see that cosine, you're going to see something lying on the x-axis. Okay? You know, cosine goes with x, sine goes with y. So then the next set would be the limicons. Limicons, there are 3 different types of limicons. This limicon over here is with inner loop. Okay, you see this part right here is what we're calling an inner loop. This one, the second one, is a special one called a cardioid. And a cardioid, cardio meaning heart, they're saying this kind of looks like a heart. But a cardioid, what's special about this is it touches the origin right there. Okay? So the others are just regular limicons, and you might say without inner loop. They all kind of look the same, and their equations are going to look like this. You're going to have either this form or this form, but the numbers are what is really going to make the difference. So with inner loop, you're going to see something that looks like this. R equals 1 plus 2 sine theta. Cardioid might look like R equals 2 plus 2 cosine theta. Without inner loop, you might have something in the x direction like R equals 3 plus 2 cosine theta, or something in the y direction, R equals 5 plus 2 sine theta. You want to pay attention to the numbers. And the cardioid is the easiest one to pick out because those two numbers will be equal. If those two numbers are equal, it's going to be a cardioid. If this number is bigger than this number, it's going to have an inner loop. Okay? Otherwise, if this second number is smaller than the first number, it's not going to have an inner loop. So those are the limicons. So we've got circles and lemniscates and limicons and roses. Roses. You want to pay attention to the number of petals this time. If we've got something that looks like r equals 3 sine 2 theta, or here's r equals 5 cosine 4 theta, r equals 4 cosine 3 theta, r equals 7 sine 5 theta. What you should pay attention to, I guess, is this number. If this number is even, we're going to have double that number of petals, of rose petals. However, if that number in front of the theta is odd, it's just going to be that number of petals. So it really, really helps to be able to classify these things. Just know what you're looking at before you even start. So some quick examples. Okay, let's try to match them up. You've got circles, lines, spiral, limison, cardioid with inner loop, limit skit, and rows. Okay, so let's look at this one. I recognize that it's one of the three limisons because it has that plus sign in it. Okay, but what you'd be looking at is that 5. That number 5 is bigger than the number 4, and so that's going to make it a limison with inner loop. I can also tell because of that cosine which direction it's going to be pointing. It's going to be pointing in that x direction. Okay. I didn't show you one of these, but r equals 2 theta is going to be a spiral. 4 cosine theta. 4 cosine theta. Oh wait, no, that's not 4 cosine theta. That would be a big difference. Okay, you notice these two look kind of the same. One of them is a circle and one of them is a rose. The one with just theta by itself is going to be the circle. The one with the 2 in front of it is going to be a rose. And not only is it a rose, I can tell because of that 2 that it's going to have twice that many petals. It's going to have 4 petals. This next one right here, again, I see that plus sign. That plus sign is going to tell me that it's going to be a limison. But when you notice those 2 5s, and those 2 5s are the same, that's going to be a cardioid. This one, r squared equals 9 cosine 2 theta. Okay, this is the only one with r squared in it. Or, sometimes you might end up taking the square root of both sides. So if you ever saw a square root, it'd be kind of the same indicator. But as is with this r squared, that's going to be the limit skit. 3 plus cosine theta. Again, the plus sign is your indicator. But since this number in the front of the cosine is 1, and that's smaller than the 3, I know that's going to be a limison with no inner loop. Okay? The last two I didn't show you an example of. R equals 4 should be easy to figure out if you know that R stands for radius. Basically, this says radius of 4. That's another circle. Okay? That's another way of writing a circle, R equals 4. And then this is the only one that's weird. Something that looks like this, 2 over cosine theta plus sine theta. That's going to be a line. So you need to be able to classify these. As soon as you classify these, the graphing is going to become a million times easier.